in this video we are going to discuss about definition of error topic, the combination of errors. Let's get started. So in this video we are going to discuss about the errors in the measurement. We know the measurement is a foundation of all experimental science and technology. We do measurement in day-to-day life. All these measurement we do with the measuring instruments. Because of that uncertainty, we won't be able to get the true value of that particular physical quantity. The uncertainty in the measurement is called an error, and because of this error we won't be able to get the true value of that particular physical quantity which we want to measure. Now here question comes, what is the true value? The true value is the actual value of a quantity as it exists in nature. It is obtained by perfect measurements without any error. But the true value is unknown because all the measurement has some degree of error. Whenever we study errors, these two concepts, accuracy and precision, are very important. Let's see what is accuracy and precision. The accuracy is the measurement of a measure of how close the measure value is to the true value. Let me take one example to explain the concept of accuracy. Let's take the true value of a weight. This is the true value. This is a weight and its true value is equal to 10 kg. Then I used one instrument and I got its value, means the measured value of the weight is to 2 kg. It is clear the measured value is not close to the true value. It means that this instrument is not correct. It means that my measurement is not accurate. So because the measured value is not close to the true value. If suppose my measured value comes out to be 9.5 kg, so now this time this is closer to the true value. So that so it means this measurement is accurate. And the precision refers to the closeness of two or more measurement to each other. So in this case I will repeat my experiment number of times. So I'll get multiple measured values. If the measured values are close to each other, then measurement has this precision factor. Let me take the previous example where I have taken the true value equals to 10 kg. So now I did multiple measurements, so I'll get number of measured values. So first measured value is, suppose it is 7.5 kg. Next second measured value is 7.6 kg. Again third measured value is 7.5 kg. Fourth one is 7.7 kg. So if we see, all these values are very close to each other. As they are very close to each other, so we can say that my measurement is very precise. The next important concept when we do the measurement is least count. Least count is the smallest value that can be measured by the measuring instrument is called the least count. So let me explain this concept of the least count by taking this scale. So this is the scale. What is the smallest value which we can measure with this scale? This centimeter thing I'm taking here. The smallest possible value we can measure with the help of this scale is from 0. This is my 0 to this, so this one, to this line. This is the smallest. This is the least count of this scale. How to measure this? We know from 0 to 1, this is equal to 1 centimeter. And we have in between 10 lines. From 0 to 1, this is 1 centimeter, and in between we have 10 lines. So we can say that these 10 lines are equal to 1 centimeter. So one line is equal to 1 divided by 10 centimeter, which is equal to 0.1 centimeter. So from 0 to this means first line, the the value is equal to 0.1 centimeter. So it means that the least count of this scale is equal to 0.1 centimeter. So this is the smallest value which we can measure with this scale. Errors in measurement are of two types. First one is systematic errors and the random errors. Let's discuss them one by one. First one is the systematic error. A systematic error is one that always produces an error of same sign, either positive or negative. These are due to the known causes. We know the cause of the errors, why these errors are happening again and again. This type of error can be eliminated by detecting the source of the error. If we are able to detect the source of the error, then we can eliminate systematic error, and further we can divide these systematic errors as instrumental errors, environmental errors, and the observational or personal errors. Instrumental errors, these are due to the imperfect design and calibration of the measuring instrument. For example, the zero error of an instrument. For example, in the vernier caliper, the zero mark of the vernier caliper may not coincide with the zero mark of the main scale. Then this is an instrumental error. We can remove this instrumental error by using another measuring instrument with perfect design and calibration. Next is environmental errors. These errors are caused by the external conditions like pressure, temperature, wind, humidity, etc. For example, the expansion of the scale is due to the increase in the temperature. Outer temperature has increased, due to which our scale has some expansion. So that also causes an error. So these external conditions during the experiment may systematically affect the measurement. Next we have observational and or the personal errors. These errors are due to the individual carelessness while taking the observations or lack of the proper setting of the apparatus. Means that person has not properly set the apparatus for taking the observations, and during taking the observation also he is in hurry, and are random errors. These errors are due to the unknown causes and are also called as the chance errors. So in this, even a person repeat an experiment may get different reading every time. For example, if we take a screw gauge to measure the diameter of a wire, experimental can get different readings in different observations, and these can be due to many reasons. Maybe that wire is not uniform, maybe the experimental has tightened the screw gauge unevenly in different observations. That's why he is getting different readings in every observation. And in order to remove this random error, we have to repeat the experiment again and again, and then we take the mean of all the measured values. To suppose that we have done that an experiment in n number of times, and we got n different readings of that experiment, and these are A1, A2 and so on till A, and then we'll find the arithmetic mean of all these measured values. And suppose that arithmetic mean is equal to A bar, and this will be equal to A1 plus A2 plus so on till A, and divided by total number of observation which are equal to n. So we can write this as 1 divided by n, summation I is equal to 1 to n AI. So this is the arithmetic mean, and this value must be closer to the true value. Sometimes we write the mean value like this: A mean, which is equal to A bar, is equal to summation I1 to n AI divided by n. So both are same. Now let's discuss about the absolute, relative and percentage error. They are very important. So let me explain these one by one. The absolute error is the difference of the true value and the experimental value of a physical quantity. And we always denote this absolute error as delta A mode. So this mode means we have always positive value of this absolute error. So let me explain this with an example. Suppose that we did one experiment, then in that experiment we got the value of acceleration due to gravity. The measured value is equal to 940, and we know the true value of acceleration due to gravity is equal to 980 centimeter per second square. So what is the absolute error is equal to delta A mode is equal to true value, which is 980 minus 940. So from here we'll get 40 centimeter per second square. So this is my absolute error. So here also we will put mode. Now suppose that my experimental value, the experimental value of acceleration due to gravity is equal to 990 centimeter per second square. So in this case the absolute error delta A is equal to 980 minus 99. We know the true value of the acceleration due to gravity, which is 980. So this will be equal to minus 10 mode. So this is equal to 10 centimeter per second square. That is why the absolute error is always positive. Suppose we don't have any other method of knowing the true value, then what we do? We repeat experiment a number of times and then we get arithmetic mean. Now suppose we repeat one experiment a number of times and we get a number of measurement values, and these values are A1, A2, A3 and so on AN. So and in that case to find out the absolute error we need to find out the mean. So that mean is equal to, we know, A1 plus A2 so on till AN divided by N. So this we can write as AN 1 divided by N summation I is equal to 1 to N and AI. So this is my mean. The absolute error for A1 will be equal to delta A1 is equal to A. In this case we will take A mean minus A1. Similarly delta A2 is equal to A mean minus A2 and so on till delta AN is equal to A mean minus AN. So for this also we'll get, now after this we'll need to find the arithmetic mean of all absolute errors, and that is equal to, we'll take the mean arithmetic mean of all the absolute errors, delta A1, delta A2, delta AN, which is known as the mean absolute error, which we represent with delta A mean, and this is equal to delta A1 mode plus delta A2 mode plus so on delta plus delta AN mode divided by N. So this is equal to, we can write this delta A mean as equal to 1 divided by N summation I is equal to 1 to N delta AI divided by N. Here we'll put mode. So this value delta A mean is also positive. And always remember that this is very important. Any measurement of a physical quantity A is likely to lie between A mean plus delta A mean. Delta A means absolute arithmetic mean of that physical quantity, and A mean minus delta A mean. So it means we can say that the value of A always lie between these two limits. So we can write this as A mean minus delta A mean is less than or equal to A is less than or equal to A mean plus delta A mean. So this relation is very, very important. The relative error is defined as the ratio of the absolute error and the true error. Means that the relative error is equal to absolute error divided by true value. Now suppose we have multiple experimental values. In that case, this relative error will become equal to the mean absolute error divided by mean the observation. So we can say that this is equal to delta A mean divided by A mean. That is the relative error. If we represent the relative error in terms of the percentage, then we say that this is our percentage error. So it means the percentage error is equal to, if we know the true value, is equal to absolute error divided by true value into 100. 100. If we have mean absolute error and mean, in that case the percentage error will be equal to mean absolute error divided by mean value multiplied by 100. So we can write this as percentage error is equal to mean absolute error delta A mean divided by A mean multiplied with 100. So next topic here we are going to discuss about the combination of the errors. So all the experiments are prone to the errors. So maybe the physical quantities involved in that formula has some errors in them. So we have to add or subtract or divide those errors according to the given formula. For example, let me take the density. We know the density is equal to mass divided by volume. So we need to find out the mass and the volume to find out the density. So maybe while doing that experiment to find out the mass, we have some errors in this mass, and similarly suppose while finding the volumes we need to find out the dimensions, and while measuring those dimensions we get some errors. So it means that we have to combine the errors of the mass and the volume to get the final result of the density. So let's discuss when the result involves the sum of two observed quantities. Let me take those two quantities A and B and their sum. The sum x is equal to x. What is the x? X is the sum of A and B. So x is equal to A plus B. Now let's suppose that delta A and delta B are the absolute errors of A and B. So it means the value of A and B should be what? A, the value of A will be equal to A plus minus delta A. Similarly, the value of B will be equal to B plus minus delta B. So therefore, let's suppose that delta x is the absolute error in the result. Then what will happen? The x plus minus delta x is equal to, what is x? Will be equal to A plus minus delta A plus B plus minus delta B. Now is equal to A plus delta B. Let me open this, plus B plus minus delta B. So this is equal to A plus B, A plus B. Sorry, here it is A plus minus delta A plus delta B. This implies x plus minus delta x is equal to, what is this? This is equal to x plus minus delta A plus delta B. So this implies this delta x, this will get cancelled with this. So we'll get delta x plus minus delta x is equal to plus minus delta A plus delta B. So this implies that delta x is equal to delta A plus delta B. The maximum absolute error of error in x is equal to the maximum absolute error in B plus the maximum absolute error in B. And this is important to not. Now next is when the result involves the difference of two observed quantities. In that case, let me take two physical quantities A and B. Then let's take the x is the value we are getting after subtract A from the B, and let's similarly delta A is the absolute value of A and delta B is the absolute error in B. Then the value of the maximum error in x that we have to find is equal to x plus minus delta x is equal to A plus minus delta A. Similarly, subtraction B plus minus delta B. Correct. So this is equal to A. If we open this, rearrange it will get A minus B and then plus minus delta A. So here the signs will get changed. It will become minus plus delta B. So plus minus delta x is equal to, this is equal to x, so they will get cancelled. So we'll get here delta A minus plus delta B. So maximum possible error in x will be equal to delta x is equal to delta A plus delta B. So we have to add here also the errors, the absolute value of A and the absolute value of B. It is very important to note that when the result involves the sum or difference of two observed physical quantities, the absolute error is equal to the sum of the absolute errors in the observed quantities. Now, when the result involves the product of two observed quantities. So, let me take again the A and B, two physical quantities, and their product is equal to x, A multiplied with B. And suppose that the absolute error in A is equal to delta A and the absolute error in B is equal to delta B. So, in this case also similarly, so the maximum possible error in x is represented by delta x. Then so therefore x plus minus delta x is equal to A plus minus delta A multiplied by B plus minus delta B. Now let me open these brackets. So here we'll get delta A x plus delta x is equal to A multiplied B plus minus delta B plus minus delta A B plus minus delta B. So this is equal to A multiplied with B plus minus A this delta B plus minus delta A multiplied with B. So here plus minus, here also this is plus minus delta A delta B. So from here we'll get this is x and this is also is equal to x. So this will get cancelled with this. So we'll get here plus minus delta x is equal to plus minus A delta B plus minus B delta A plus minus delta A delta B. So dividing both sides with x is equal to A B. So we'll get here plus minus delta x divided by x is equal to plus minus A delta B divided by AB plus minus B delta A divided by AB plus minus delta A delta B A divided by B. So here we'll get is equal to, this A will get cancelled with this A. So we'll get here plus minus delta B upon B. From here B will get cancelled with B plus minus delta A upon A, and next plus minus delta A upon A multiplied with delta B upon B. So we can rearrange it and we can write it as plus minus delta A upon A plus minus delta B upon B plus minus delta A upon A multiplied with delta B upon B. What is this delta x upon x? This is the relative error in x. Similarly, delta A upon A is the relative error in A. Delta B upon B is the relative error in. This implies that this is equal to delta x upon x is equal to delta A plus A delta B plus B. So this is the maximum possible relative error in X. Here we are selecting this factor because this is very small. So we can take its value equal to 0. So from here we can get the maximum percentage error in X, which will be equal to delta X upon X multiplied with 100 is equal to delta A upon A into 100 plus delta B upon B multiplied with 100. So this is the maximum percentage error in X. So last one is the when the result involves the quotient of two observed quantities, means division. So in that case, let me take two physical quantity A and B, and delta A, delta B are the absolute errors. So in this case, we'll get X, so X will be equal to A divided by B. So here also the maximum possible error in X is equal to X plus minus delta X is equal to A plus minus delta A divided by B plus minus delta B. So this will become equal to A plus minus delta A, and we can write this as B plus minus delta B inverse minus 1 here. So now we will take the A common from here, A. So I'm taking here, so I will be left with 1 plus minus delta A divided by A. So similarly from here I'll take B out, so I can write this as this A divided by B. So here 1 plus minus delta B upon B raised to power minus 1. Now here we'll apply the binomial equation. So we'll get A divided by B multiplied with 1 plus minus delta A upon A. So here we'll get 1 minus will come here and plus sign here delta B upon B, and after that we'll get some higher powers of delta B upon B. They will become very small and we can neglect them. So therefore we'll get maximum possible error in X as X plus minus delta X is equal to A divided by B, 1 plus minus delta A upon A. So 1 here also minus plus delta B upon B. Multiply these two terms, so we'll get A plus B. So here we'll get, I'm not going to explain anything, so try to do yourself. So we'll get here plus minus delta A upon A, and minus plus delta B upon B, minus plus delta A upon A, delta B upon B. Again this will be very small, so we can neglect it. So we'll get here X plus minus delta X is equal to this 1 plus minus delta A upon A minus plus delta B upon B. So we know this is equal to X. So we can write this as X plus minus delta X is equal to X into 1 plus minus delta A upon A minus plus delta B upon B. So this will be equal to, I'll take this down, so I'll get here 1 delta X upon X is equal to 1 plus minus delta A upon A minus plus delta B upon B. At X divided by X plus minus delta X upon X is equal to 1 plus minus delta A upon A minus plus delta B upon B. So this is equal to 1. So this is 1. Here also we have 1. So they will get cancelled with each other. So we will be left with delta X plus minus divided by X is equal to plus minus delta A upon A minus plus delta B upon B. So maximum relative error in X is equal to delta X upon, so delta X upon X is equal to delta A upon A plus delta B upon B. The maximum possible relative error in X is equal to the sum of the relative errors of A and B. Similarly, we can find out the percentage error, which will be equal to delta x upon x multiplied with 100 is equal to delta a upon a multiplied with 100 plus delta b upon b multiplied with 100. So this is the percentage error in x. So this is very important to know that when the result involves multiplication or division of the two observed quantities, the maximum possible relative, here we have relative or the percentage error in the result is equal to the sum of the relative or the percentage error in the observed quantities. So this is very important to note. So next we have when the result involves the product of powers of observed quantities. So let's take we have a physical quantity a, then x is equal to a raised to power n. So in this case we have to differentiate it to find out the error in this x. So now let's differentiate with both sides. So differentiating both sides will get delta x is equal to a raised to power n minus 1 delta a. Now dividing both sides with x is equal to a raised to power n, will get delta x upon x is equal to n a raised to power n minus 1 divided by a raised to power n delta a. So from here we will get delta x upon x is equal to n delta a upon a. So this is very important to note that. Here also we will get the relative error n times the relative error a. Now suppose we have a formula like x is equal to a raised to power l and b raised to power m divided by c raised to power n. So in this case we have powers l, m, n and multiplication and division also. So in that case then the maximum relative error in x is equal to delta x upon x is equal to this l will come here delta a upon a plus m times delta b upon b plus this n will come here delta c upon c. Similarly, we can find out the percentage error in x, which will be equal to delta x upon x multiplied with 100 is equal to L delta a upon a multiplied with 100 plus m delta b upon b multiplied with 100 plus n delta c upon c multiplied with 100. So in next lecture, we will do the questions related to errors. So revise everything related to the error before watching my next video.